right, cool. I think with that, we will get started. Thank you everyone for joining today. My name is Matt McGurk, and today we're going to be discussing some kind of do-it-yourself pitfalls in PCI DSS compliance and security. So basically, as folks start to think about or continue to think about, or maybe you should have started thinking about how to solve for PCI DSS 4.0 requirements 6.4.3 and 11.6.1. We wanted to make sure that people understand what the guidance in DSS really recommends as far as CSP and SRI, how they can deal with it, and what they might want to consider before they head too far down one of those roads as their own approach. My name is Matt McGurk. I'm our head of field engineering here at Source Defense. I've been with this company for nearly 7 years now, since its inception. So I consider myself, for better or worse, an expert in this subject matter and things related. And I have a pretty extensive background in web application development as well. So as I said a couple times now, for people who've been on the phone throughout the session, if you have questions either about the technicals or about anything else, please let me know. I'm happy to take those as they come, and there'll be some time at the end as well for that. So as I was preparing for today, really the what brings us here together is one very specific part of the PCI DSS 4.0 requirements and the guidance provided. So let me just actually put this in the constellation of things overall. PCI DSS is the standard that merchants and payment service providers have to adhere to if they have cards going through their business, payment card data going through their business. Requirements 6.4.3 and 11.6.1 are particular to web pages where payment card data is entered or displayed or manipulated. And in requirement 6.4.3, there's some guidance, literally, that calls out two different technologies: sub-resource integrity and content security policy. In addition to that third bullet there, of course, a proprietary script or tag management system. So the first two things, though, there are obviously examples of what one could do, what an in-scope organization could do in order to solve this problem and or meet these requirements. And as a result, lots of folks start to look at this as the first way, or maybe even the only way, to satisfy these things. And that's, in our opinion, in my opinion, both technically and as a representative of Source Defense, is really a false start. It's not a good way to do it, and also trying to do it may delay the overall thing you're trying to accomplish, and it also may lead to a situation where you're not very secure. So the goal of today's webinar, although I do have opinions on this, is to provide a rundown of what these technologies are, a little bit about how they're implemented, and some considerations that you should take into mind as you think about these and how you're going to solve for 6.4.3 and 11.6.1. So I want to take a step back a little bit and just frame the problem so there's some common language between us, between myself and the audience here today. So we're talking about web applications and web pages. One term in the security community for that is a client-side attack. And the way that those happen is because of choices, architectural choices that happen inside of the web page as a visitor is interacting with a website. So a visitor in their browser hits a particular location on the internet. Along the way, that communication is protected by what I would call a traditional web security stack, things like a firewall, TLS, SSL, other technologies. And those are certainly important. And they do have applications in other parts of DSS, specifically like WAFs and such. There are strict requirements about what you have to do there. However, in this particular arena of 6.4.3 and 11.6.1, they don't do anything. None of those technologies are going to really help you thwart an attack that happens inside of the web page. Inside the web page, you've got a lot of different kinds of code, a lot of different kinds of JavaScript. One of the more difficult forms of it to handle, to manage, is called third-party JavaScript. Those would be integrations from a marketing technology vendor, from social media, et cetera, et cetera. Basically, generally speaking, these are tools that are used to enhance the revenue that a website generates. And as you might imagine, the closer you get to a sale, to someone entering a card number on a website, the more valuable information is about that visitor and their behavior. If there's something that you can measure and monitor that gets someone to click the buy now button more frequently, that is a very good signal to collect, and hence the really strong and continuing integration of these kind of tools into very sensitive parts of a web application. So all this stuff loads into a web browser, and it's important to note that JavaScript inside of a web page has, by default, or rather by kind of out of the box, I guess, has no security controls, has no idea of a permission model or anything else. The code just runs out there in browser land. The organization that serves the website has really no way to monitor what it's doing or what it might be doing to the visitor's experience. And it has no controls put around it as far as what data it can access and so on and so forth. And so this is really why this unsecured part, this architectural flaw that was created about 20 years ago. What year is it? About 25 years ago, when JavaScript was specified in the first place. Nobody thought about security, and so we're all kind of reaping the consequences of that decision. Hence, DSS says we have to put something in there to secure this code and monitor it. Attackers know about this. They take advantage of the supply chain effect, and they do things like either poison some part of the supply chain, meaning it would not be the merchant. I'm going to use the word merchant, by the way, and payment service providers relevant here too, but I'm just going to start saying merchant for the sake of conciseness on this call. So the merchant doesn't host this code. They kind of just instruct their webpage to go grab the code from somewhere else. Or in the case of further down the supply chain, it is the integration, which is calling another party, a fourth, fifth, sixth party. So the attackers know this and might choose to go somewhere further down the food chain to get into not just this advertising tool, but of course all the web browsers and all the advertising tools where that web page is being loaded. So it's a very wide attack surface, or rather, exploitation surface for the attacker. More often than not, what the attackers do is steal data out of the web page at runtime, meaning that they will skim card numbers. eSkimming is the language that DSS likes to use primarily. There's also another kind of, so that would mean literally taking the keystrokes as the visitor types them into a form inside of the web page, and just like a gas station skimmer at the gas station pump is siphoning off the card numbers. The other form of this attack, which DSS and the guidance they provided, the Security Council provided, has also started to use the term double entry attack. And that would be where the attacker injects their own form into the page, has the person enter their card number into that attacker's form, and then removes it after one submission and shows the actual payment form. So it's kind of a bait and switch, like a sleight of hand thing. The reason I point that out is sometimes the question gets asked, well, how can someone skim card numbers if the page is using an iframe, an inline frame that should secure and kind of isolate the attacker from the sensitive information? And the answer is that double entry attack, where the attacker introduces their own form, lets the transaction fail once, and then shows the actual legit hard entry form. So these are how these attacks happen. And that's what brings us together today. Those two technologies mentioned in the DSS guidance are, like I said before, content security policy and sub-resource integrity. And they are usually what I call well-intentioned technologies. They're part of the World Wide Web Consortium specification for how the protocol, the hypertext transfer protocol, how browsers and servers talk to each other. So they're part of the standards. They're not like a vendor product, although there are certainly vendors in the space who have productized around this, who offer some way to like manage your CSP or other things, but they're just part of the spec. And that's often why they get rolled into this kind of do-it-yourself approach, meaning that an organization, a merchant, will choose to take the work and the solutionizing, to use a word, to solve this problem in-house. And then they kind of see, oh, CSP and SRI, they're part of the spec. Wait, okay, so our devs think they can do it. Let's give it a shot. So what I want to do here in the next couple of slides is just walk through what these actually are and how they work. Not in an overly technical sense, but just, what are we proposing here? So CSP works like this. It is basically a whitelisting technology. There's a little bit more to it. There's some stuff about kind of like where can scripts load from, or rather where can they talk to, and a few other things. But the basic idea is to make a list of all the locations of all of those third-party integrations and fourth-party and et cetera integrations in the web page, and then put them into part of the web page configuration. To get into the technicals just a little bit, these can either be served as part of the headers of the web page. The headers are the metadata that is served from the browser, from the server into the browser. So we as visitors never see that information, but it is important to how the browser will kind of interpret and display the content of the web page. So you can put CSP in there. You can also put them in what are called meta tags, which are basically headers, but inside that I won't get into it. But those are the two ways to do it. The takeaway there is that you, the merchant, are putting these into your web application. You're deriving a list of all the places all of the JavaScript in your page comes from. You are then putting that into a particular format, what's called a CSP directive, and then you're putting them into the server. And then that list heads out into browser land and gets loaded every time the web page is interpreted and executed. The web page then at runtime looks for stuff like, well, it compares the list really. So the browser tries to load a bunch of scripts. It says, hey, for each of these scripts, go and make sure it's in the whitelist. And if it's not, then block it. And that's the basic idea. I'll give you an example here just because why not? So here's a browser. I have it open to the CSP page in the Mozilla Developer Network. If you guys want to look up stuff, I like the Mozilla developer documentation a lot for a bunch of different reasons. But this web page is not just about CSP, it also has CSP in it. So what I'm going to do here is inject some arbitrary code into the Mozilla web page here. And when I execute it, you can see this red error message pops up and it says it's violating part of the CSP, this directive saying that scripts can't get added from this particular domain, more or less. And you can even see the rest of their actual CSP directive. These are the places that are permitted from which code can be loaded. And I didn't plan this, but CodePen, by the way, was kind of discovered by our researchers yesterday as hosting a whole bunch of MageCart attacks. So I don't know. Sorry, I'm just kind of thinking this through now. It's not great that this particular domain is in this particular CSP directive because it means that if someone wanted to load one of those malicious files from CodePen, it would be permitted by Mozilla's CSP right now. So not great. But you can see the effect of CSP. This script that I tried to inject is not in this list below. And so the browser threw this error message and said it didn't load. While we're here, yeah, why not? While we're here, I wanted to point out a couple things about this. First of all, this is very much literally a whitelisting, blacklisting approach. So there's no notion here in CSP of what was this script that I injected trying to do, or what should it do, or what can it do? There's no permissions here really. It's just is it coming from a trusted source or not, a trusted URL or not? The second thing about it is that this report, I think, is actually kind of interesting. So this is literally what happens when CSP gets violated, is a red-ish error message pops up in a console somewhere in a web browser. It does not by default get reported anywhere. To do that, you have to, let's go find it in here, specify a report directive. And let's see does Google do one, or sorry, Mozilla do one here? It doesn't look like they do. So reporting directives. So I wanted to point this out. This webinar is a little more technical than my usual, but I hope not too very much. What I'm trying to get at here is if you want these error messages to go somewhere, like if you were Mozilla and you want to know when this happens, you have to kind of develop your own reporting tool or use some other kind of reporting tool. So this message doesn't kind of end up back on the web server somewhere for me to interrogate and look at. It literally just happens out here in browser land. If I want the reports to go somewhere, then I have to use the report to directive. And I also have to have an endpoint somewhere that can consume that message. So unless you have a tool already that can consume something from the HTTP reporting API, or you want to build your own, these CSP messages won't go anywhere. They'll just kind of be here in the browser and etc. The other thing I want to point out is that on the odd occasion, you do see this out here in the wild, so I'll mention it. It's a valid testing tool, but you can implement CSP in report-only mode. That would mean that those error messages get thrown, but not enforced. So that's a good way to test, but sometimes you do see this happening out in the wild, in production, I mean, for one reason or another. And so if you are assessing or auditing this or trying to understand your own security and compliance, be on the lookout for this stuff slipping into prod, because then your CSP isn't actually doing anything. So that CSP, I kind of delved into a little bit more of a demo and some commentary there, but let's talk about sub-resource integrity as well. So you may have been thinking, well, if this thing is just a CSP, it's just going to determine where scripts can load from or not, then, sorry, I'm just seeing the questions here. Yes, we will be providing a recording of the presentation afterwards, no problem whatsoever. I'm also available for children's birthday parties if you want, and you have some very nerdy children. But in all seriousness, sub-resource integrity. So a CSP is about kind of like from what locations can content be retrieved and executed. Sub-resource integrity is then we need a way to make sure the content itself hasn't changed, its integrity is assured. And as a side note, sub-resource integrity, as we showed at the top, is in the example guidance for DSS 4.0. It is also, the word integrity is also called out in 643 itself. Let me just go there now so we can have it. So in 643, you've got this language about a method, the middle bullet there on the left. A method is implemented to assure the integrity of each script. So one might be led to the idea that you need to implement sub-resource integrity in order to be compliant with 643, which is not the case, by the way. At least according to some of the folks who I've spoken to who've written the spec or at least contributed to it, the idea with the integrity in 643, let me just go back there so that I don't do the same thing DSS did. The idea with this word integrity here is the NIST, the National Institute of Science and Technology, I think, or Standards and Technology, definition of integrity, meaning that the script has its location is non-repudiatable. It can't change without you knowing about it and a few other things. So this integrity has another specific technical decision or definition that is not the same as sub-resource integrity, just to disabuse anyone of that notion. You don't have to do this in order to satisfy 643, but if you chose to do it, this is how it works. So you would need to analyze all the source code, all the JavaScript loading into a payment page, and you'd need to generate hashes or fingerprints for each one. Again, this happens before like the browser, before any of that stuff. It's a development task, basically, where one of your web devs or the equivalent would have to download all the code, including from third parties. You'd have to run it through some kind of hashing algorithm and then put that into either the headers or into the tags themselves. Point being, you put them into the web page. What happens then is the server serves those hashes out to the browsers, to the visitor's browser, along with the rest of the content. And then as the browser retrieves those files from those third-party sources or your own first-party sources, it generates a fingerprint for that just retrieved copy of the file. So you've got a known good signature. We've got a new file. We're going to generate a hash for the new file and compare them. If the new hash and the known good hash match, then the file is allowed to load and can execute. If the hashes of the fingerprints do not match, then the script is blocked from loading and it will not load. And again, the language throughout here says third-party script. It applies to first-party scripts as well. It can apply to whatever. Actually, sub-resources can be any element of a web page, if anyone was curious, including like images and other stuff. But in this case, any JavaScript file can be treated this way. And if the hashes do not match, then you have a problem and the browser will refuse to load those other scripts. There's a couple issues with this that we'll get into further, but the idea here is that these two technologies are kind of complementary. The first one, CSP, is meant to verify or to lock down locations, whereas the second is meant to lock down file contents, right? And just, I don't know, by way of further commentary, these are well-intentioned technologies. I'm not just trying to like dunk on the World Wide Web Consortium for making the design decisions they did. They, in my opinion, are suited to a couple of use cases. Like if you own a web application entirely, like let's just pretend I have the world's simplest web application and I don't know, I fill out time cards on it. It's like a time clock for my business. I own that app. I have the infrastructure for it. I own the code development process and deployment process and everything else, right? Then CSP and SRI might be for you because I control what code is coming out when and where it's coming from and everything else. So I'll explain more about why that doesn't usually happen in a second. But in that particular case, maybe CSP and SRI are the way to go. Once you get into any kind of like modern public-facing or customer-facing website of any complexity whatsoever, that use case starts to kind of fall apart and CSP and SRI become much less effective. This all wraps back around to requirements 643 and 1161 and what they ask us to do as in-scope organizations to be compliant and to be in the good graces of the Security Council. So 643 and 1161 basically, in my opinion, boil down to just a few things. For instance, you have to inventory any payment page scripts. So you have to know what's there, and you have to make sure it's authorized to be there in bullet 2, as well as providing a written justification, a technical or business reason for each payment script to be on the pages. You also have to implement a method to assure the integrity of each payment page script, as we discussed a few minutes ago. So having a way to know if it changes, or if it's doing something bad, or if it's being served from somewhere you didn't expect, and so on and so forth. The 1161 then is the complement to those items, and basically has to do with tamper proofing. That you have to have a way to know if script contents change. You have to have a way to know if the headers change. And by the way, if you recall from closer to the top, because CSP is implemented via the headers, that's really why this requirement exists. So even if you choose another approach that does not require CSP, you still have to check the headers, and that's why. In case you were curious, like, well, I'm gonna implement source defense, or I'm gonna implement something else. And why am I checking headers? Because CSP, you can kind of see where I'm going with that. So it's not a bad idea to check security affecting headers anyway. It gets kind of weird once you start implementing a different approach to doing it. So you can kind of see the outlines of what they're trying to get at here, and et cetera. For anyone who's not familiar, about 3 weeks ago, I want to say, the council released a guidance document called the Guidance for PCI DSS Requirements 643 and 1161. It's available via their website. It's a good document. I contributed a very small part of it, in addition to 60 or 70 other experts and people who are smarter than me. But it's a good document. It explains a lot of this in greater detail than we have time for today. But I wanted to bring to your attention this particular table from it. And shout out to Gary out there. The table was a good idea, and it got to the final form that I think is very useful. But what this does is lay out those different items that I boiled down in the prior slides, and talk about what controls you could use to help meet those. So this isn't kind of a menu, right? This isn't like, oh, I pick 3 things out of each column and then I have a coherent solution or a compliant solution. This is more like a compass, in my opinion. So this is kind of like, oh, I'm trying to meet these different parts. I'm trying to do these different verbs in the standard. What can I use? What's a good direction to take those? And you'll notice that almost every single one of these has CSP in the middle column here. But it gets a little weird because none of these in and of themselves is a complete, one-stop shopping way to do this, because they're controls and techniques. They are ways to overall get a solution together for your organization. You should consider each of these as kind of its individual task, and then decide which of these different controls or multiple controls from each category are you going to use to implement it. But I mean, for example, inventorying, right? CSP could help me enforce an inventory. It could help me say, only load these scripts that I have already identified as essential to my web pages, my payment pages, but it won't build an inventory for you, right? So I think this table is very interesting to consider, because it highlights that these things in the middle are techniques rather than holistic overall solutions. And let's see, anything else I want to point out about this? Not exactly. I think that it's interesting to me that, yes, SRI only comes up here in the context of integrity. SRI really doesn't have any reporting itself as a technology. It kind of doesn't do very much else except that hashing and comparison. So it is pretty limited in its application. The other thing that you'll see come up in here over and over again is web page monitoring. I think it appears in every single row in this table. So you're always going to have to do some kind of reporting and some kind of monitoring for what's going on inside of your web pages, and CSP does not always do that. Even if you report on it, you're getting pretty blunt and overall reports, meaning that, hey, something failed to load, or et cetera. And I think that's also an interesting point to bring up here to reinforce a little bit. When CSP or SRI forbids a script to load, it does exactly that. It simply says this script may not load now. And so if that script was essential for the execution of the page or for the completion of the transaction or whatever, you're just going to break the page. There's no kind of granularity to it, or kind of, I want the script to not access certain kinds of data. It's simply on or off. And the consequences thereof can be very tricky. The other note, well, yeah, let's keep on trucking, and we'll work the rest of this in here. I wanted to pull out a couple of other items from the DSS guidance document, rather the SSC guidance document. These were their criticisms of CSP and SRI. And, I mean, obviously I'm critical of them. I don't think this is the best solution for the problem, but this is more about like, if you are going to go this route, here's some good advice to try to accommodate, or there's some disadvantages to accommodate as you go. So you will need to make additional, if you're using CSP, you're going to need to do additional stuff to handle. So basically, if you look back at that table, although CSP gets called out in each of those different categories, it's not going to do it on its own. For things like authorization, which is really more of a governance task, I mean, authorization just means someone at your org has blessed the particular script as being relevant to the page. No technology really can do that for you on its own. Tracking header changes, we talked about that. So because CSP itself is a header most often, it can't track itself in that fashion. I think the second bullet, particularly the highlighted part, is very interesting and important. So in a dynamic environment, it can be tricky to do this. What do they mean by dynamic environment? Well, let's actually just take a look at something here. So I'm going to load up, how about the New York Times, who I usually click on. So here's the New York Times. They have a website. It's complicated. And what I wanted to point out for you here is when I load the web page and I show you in the developer tools all the JavaScript that loads here, I wanted to point out that a lot of this code, especially the marketing stuff, will actually boil in things like, for instance, this is a very good example. You see this random string of characters here. This is some kind of tracking number or some kind of global unique identifier or something else that helps this script, this Google ad syndication tool, track me when I load this page, or et cetera. And so the point I'm trying to bring to light is that this particular script, when it's loaded, does something dynamically to change itself to make it relevant to just me. It becomes unique in a way. So you can see like here in Sentry, here's another ID number that was put into the script file by this other server, or rather the Times in this case, but the point holds. The server on the other side, the web application at the third party, is literally changing these files at the time my browser asks for them. And so the question there becomes, how does one apply something like SRI to those scripts that change all the time? How can you hash something that doesn't have a solid, continuous, known good baseline copy? You can't. The hash will always fail for dynamically generated scripts. The second thing to consider with the dynamism thing is what we're talking about here, is that third-party infrastructure changes. So what I mean by that is today, if I were working for the Times and I wanted to implement CSP, I would go through this list and I'd find all these domains and I'd find all these URLs and I would put them into my CSP directives. The trouble with that is if any of these other parties, these third parties, fourth parties, et cetera, change their infrastructure, like, look here, we're seeing page add2.googlesyndication.com. If page add3 shows up tomorrow, or they change something else about their infrastructure, my CSP is going to be invalid and is going to block that advertising technology, which may be directly related to revenue. So the point I'm trying to make here is that if one has a situation like this, or even something remotely like it, where you're relying pretty heavily on third-party infrastructure, maintaining CSP and SRI for those things, especially with hashes, can be very challenging, if not impossible. And also, I would mention that this is kind of something you see a lot is that people will implement content security policy, and they will basically erode over time, to put it a particular way. What I mean by that is you start out with a very well-intentioned, kind of well-put-together CSP policy that catches all this stuff and manages all of it. And then Google changes something about their infrastructure. So suddenly there's somebody on your side says, okay, let's put a wildcard in here for all the Google stuff. So anything that loads from Google can load from wherever. Okay, well, then we need to do this for other stuff. We'll make this wild. At the end of the day, it ends up just like all being wildcards. Or worst case, it turns into report only. And then you just have one thing that doesn't do anything. It just reports. But you can say on something like a scoring, like a securityheaders.com, oh, we're implementing CSP, so the box is checked, when it doesn't actually do anything of any particular interest. or use. The deletions and security impacting headers. Whoops, sorry. Right, I mentioned this before, but basically that CSP cannot detect itself being removed from a web page. So you'd have to have another mechanism to monitor the headers on your page to make sure that they weren't removed. So that's an interesting note. It's kind of a cousin to the report API stuff. So not only do you need an endpoint for the reports to be sent to, but you would need a way to check on your own homework to make sure the CSP directive themselves aren't removed. SRI is a more straightforward kind of list of caveats. Rapid changing scripts, that what I just described with the dynamic scripts and et cetera. Basically, that if your script hashes are not pretty solid and change dynamically, then you're going to have trouble. SRI, this is interesting. SRI fails pretty silently. I'm not, I could be wrong. I doubt it. That sounds arrogant. But when last I checked, SRI does not have the report API kind of endpoint stuff in it. It can't serve out error messages of its own volition into the ether. You need to do something else with JavaScript to monitor those sorts of things and take care of them. You can also, I should mention, implement hashing stuff via CSP, which I know sounds a little confusing, but you could put hashes into CSP as basically sources. So that case, you could report out of it, but the SRI technology itself does not do a very good job about reporting or about failing in an interesting way, meaning like failing in a way that's useful for you to diagnose what's going on and make changes. So those are the requirements there. But SRI is kind of its own. It's kind of a cousin, kind of a necessary cousin to CSP. You pretty rarely see SRI implemented on its own, but those are certainly considerations with it. Let's talk a little bit about what source defense does for just contrast. And obviously, we got to keep the lights on. But one might wonder, what else can you do besides this if CSP and SRI don't work very well? And we'll go back to this guidance here for a quick second. The third option in this, or a blend of these options, of course, as that table pointed out, but will be a proprietary script or tag management system which can prevent execution of malicious code. And so basically what we're saying here is, and they're saying, is putting something inside of the web pages to secure things. You may have in market also heard things like an agent-based solution, meaning that something's installed inside of the web pages. We like behavioral integrity monitoring and a couple other similar terms. So the idea here, I'm just pulled a couple quotes from some white papers that we co-authored with Coalfire and Viking Cloud. The first idea that Coalfire likes espouses, and I think accurately, is to think of the overall payment flow, meaning that you should be thinking about not just like literally the individual payment page document, although depending on your own assessment, your own needs, that might be the scope of what you're doing, but think about everything that looks like the payment process to the visitor to your site. We kind of saw this clarified a little bit with if anybody saw in the new guidance the language around single page applications, where in the guidance documents, SPA's single page applications are pretty broadly scoped now, like the entire application's in scope. So this is a similar idea where make sure you're looking at not just, I guess the idea here is like not just one page and not just the headers on those pages, but anything that's part of the payment process and any of the different things that boil into the security of that process. So a more holistic view. And then Viking Cloud, a little more direct to the point, talks about behavioral management. So looking at the behavior of scripts and what they're doing as they run inside the visitor's web browser, rather than just where they came from or what the hashes of their files are. So what that means in a practical sense for us here at Source Defense is our tools like this. So this is an example of our platform. This is a particular marketing script that's running on one of the sites we're protecting. And it's the ability to see things like this over here on the right. So what is a script actually doing in an interesting, qualitative, human readable sense, as opposed to just a file hashing approach, and a way also to track those changes. So what we do is record all these different signals and boil them down into these behaviors, and then give our users a way to acknowledge the appropriate behaviors, and then get notified when the behaviors change from that acknowledged baseline. So if a script starts doing something new and weird, like accessing card data or loading content from a suspicious domain, we would notify the administrator of the system and let them know, hey, there's a new domain name that's getting accessed, or there's a new kind of information that's being retrieved from the page, or certainly things like card data or passwords are leaving the web application, the payment pages. And so this behavior-based approach, rather than hashing, rather than other similar techniques, is more effective for actual humans, we find. The second thing from us or from any other mature solution in this space that I would expect to see is automatic inventorying. So we do that as well, meaning that we're going to show you automatically all the scripts and all the services that load into a given website without any manual investigation. The way our tech works is you point it at a website or you deploy our code into your site, and then we will handle the rest of it from there. So there's no further inventorying required or anything else. Once we're deployed, we simply populate these interfaces. And so the theme overall, I think, for this stuff is if you're going to go with a vendor-based solution, you should be looking for something that makes things actually easier to accomplish the task by automating as much of this process as possible. As you probably gleaned from the overall conversation today, the CSP SRI approach is pretty burdensome from either an initial implementation standpoint or for an ongoing maintenance kind of sense. And so a tool in this space, in my opinion, should take a lot of that work off of an individual by being as automated as possible. Let's see what else we got on the docket for today. So I think that is the majority of the information I wanted to cover. I'm going to open it up for more free-form Q&A at this point if anyone has those questions, and I'm happy to take the discussion in any particular direction. Well, maybe I'll leave this table up here because it is, I think, interesting. Yeah, I thought it was pretty good. It's long, don't get me wrong. It's about 60 pages, I believe, but it does a very good job of, probably better than I did, being more concise, of outlining the underlying issues at hand. And I liked some of these descriptions as well too. But nonetheless, I'd encourage you, if you haven't seen it, to look it up. And we'll throw that link in the chat too. Yeah, this stuff is pretty useful too. The iframe description describing who has scope and who it belongs to, as well as that definition of, well, here's the single page thing. I know I'm rambling now, but the single page thing, for anyone who's unfamiliar, single page application is basically one web page that reconfigures itself, changes itself on the fly over and over again, but the browser really never loads another document. And so in those cases, basically the entire application is a payment page because a payment form can appear at any point in that. The other thing I thought was particularly interesting in here were those double entry skimming and silent skimming definitions. Again, this is where the silent skimming example is where literally keystrokes or other information is taken out of form fields on the web page. And the double entry attack is where a malicious form is injected over the legitimate payment form and then is removed after one entry into there. So these definitions, I think, are interesting to frame the conversation as well. Let's see. Is there any information on the document or others regarding the use of RASP? So that's real-time application security and hardening. So basically, I would argue that let's see, and this nothing specific to be honest, but I would argue that web page monitoring, as well as what they're calling in here proxy-based solutions, which, by the way, in this case, I believe the term proxy means more not like a web proxy where there's a host in between the web server and the web browser manipulating information. The proxy here would be a piece of code that sits in between the third-party JavaScript, for instance, and the normal execution of it in the browser. It's a bigger topic, but nonetheless, I think I would argue that web page monitoring and proxy-based approaches fall into the DAST or RASP kind of category here. At least they're like an active security technology that gets integrated into the app at runtime. But at least I've been doing this for a little bit now. I haven't seen anybody truly try to apply DAST or RASP to this area. It's just a little bit different, although we're getting there every day. So the point here is that CSP, SRI, and RASP put together would make a good solution. I don't think there's any doubt about there being a bunch of different ways to combine these different kind of Lego pieces into a solution. I think the question that just like anything else, you should ask is like, what kind of project are we signing up for and who's going to do it? Now, I spent a long time, like 15 years being a web application developer. And usually, at least when I was younger, what we would say to any problem is, oh yeah, we can do that. Like, no problem. Yeah, I'll put together a solution for that because, we're good at stuff. And then, of course, you try it and it doesn't go so great. And then you need to backtrack and find another thing. So I guess these requirements kind of showed up and were new. The topics were new for a lot of people. And I guess that maybe the idea was kind of like, oh, this can't be this hard. Like it's two sub requirements in the overall DSS. We'll knock it right out. But then when the actual complexity of the task was fully realized and kind of fully scoped out, it is a pretty big project. I've done some kind of back of the cocktail napkin kind of analysis, and I think it's not out of the question to say like 100 hours or more to do an initial deployment, like an initial build and deployment of a solution that kind of puts together a bunch of different of these approaches on your own. Now, I mean, of course, I'm talking to you from a vendor, so I have my own opinions about how this should be solved. But I do think, at least for this first year, and probably for another little bit, that a commercial off-the-shelf solution is probably the most realistic thing for most people. We'll see how the space evolves, but it's just a big engineering ask to do this stuff in more of a bespoke fashion. But it's an interesting and hard to solve puzzle. So that's kind of why engineers sometimes get stuck in it, I think. It's a very attractive Venus flytrap for the engineering mind. All right, cool. We're going to call it there a little bit early. If anybody has questions or follow-ups or anything else, my name is Matt. I can be reached at matthew@sourcedefense.com. If you hit up our website, you are more than welcome to get some time with us, talk about your own specific use case, and figure out what you might want to do there. This little module at the bottom or this request a demo here will take care of that for you. And we'd love to speak to you more directly and answer any questions you have. I hope the rest of you have a great day. And we really appreciate you joining. Thanks so much.